sent, this frame will be sent to all the destination. And when I say all the destination is that, I mean to say all the ports which are connected on that local area network, right? So if you see here, the frame which is sent by PC sales A is being forwarded to all the ports except the one which it received. Hello and namaste dosto. Welcome back to our channel. In today's video, we will talk about another interesting topic, which is the VLAN, virtual local area network. That is where we will try to understand why do we need a VLAN at all? How does it work? And what is a VLAN, right? Also, we will try to go through some of the configuration section. So if you have not subscribed our channel till now, please go ahead to subscribe it and share with your friends and colleagues so they can get benefited out of it. Okay, so let's start. So in this one, first, as we mentioned, that we will try to understand why do we need a VLAN. And for that, we need to understand the broadcast and the broadcast domain. So how the broadcast frame looks like. So here we have how the broadcast frame looks like. So if you see here, we have the source MAC address, which is listed here, right? Which is the sender MAC address, right? So what is this? Sender MAC address. Now the destination MAC address is the magic here, which is the broadcast. So what does it mean by that? FFFFF is the broadcast MAC address. So what does it mean by that? If any frame is being sent, this frame will be sent to all the destination. And when I say all the destination is that, I mean to say all the ports which are connected on that local area network, right? So if you see here, the frame which is sent by PC sales A is being forwarded to all the ports except the one which it received. What does it mean by that? That the frame which is sent by sales PC is, as soon as it received by the switch, is forwarded to all the ports towards to this one, towards to this one, towards to this one, and this one, right? Except the one which it from on which it received, right? So the broadcast frame is being forwarded to all the ports into that lane from other than the one which it received, right? So for an example, in this one, it received on this one. On this one, it will not send back, but the frame will be forwarded to rest of the port, right? That's the broadcast, right? Now, what is the broadcast domain? The broadcast domain is a boundary until the broadcast frame can be forwarded, right? So here, what is the broadcast domain? It is a one broadcast domain. This is the entire broadcast domain, correct? Now, just think of that. It is right now we are talking about the 5 PCs, right? And out of those 5, right now, 1 PC send the broadcast. Now, just think of that, these all PCs send the broadcast. And if you have a bigger network, right, you have 1,000 or 2,000 PCs having in a one broadcast domain, all the time someone will keep sending a broadcast, and that will affect the performance. How? Because at the end of the day, all the frames are being forwarded on the switch, right? Or any switch which is connected into this network will be further forwarded to all the ports other than the one it received. So that means to say it is going to use the memory and CPU of this switch, as well as the link capacity of the links, and going to disturb all the ports which even don't need it, right? So what is happening? The broadcast is the one where the frame is forwarded to all the destination. Destination is unknown, and the broadcast domain is a boundary of that broadcast, correct? Now here in this scenario, we have a one broadcast domain, right? Now we will take another scenario where we have split the sales and IT, and how we split it is that we put the one router, right? So if you see here that PC sales PC A and sales PC B is connected to the switch, further it is going to the R1 and R1 is going to the R2, and that is how it is going further connected to the another switch which is connected to the IT department, right? Now this is the physical segregation which we did to break the broadcast domain. How? Because what I'm saying is that any layer 3 device, either it is the router, it is the layer 3 switch, or firewall, or any other device which have the layer 3 capability, does break the broadcast. So broadcast is limited to the layer 2 domain, correct? So broadcast is limited to the layer 2 domain. So in this case, let's assume that sales send the frame to the switch, right? To the switch. As soon as the switch receive, it forward to this one, it forward to this one, right? So what is happening? That this frame is similarly the IPPC sends this broadcast. This broadcast And this, as soon as the switch will receive, switch will forward it to the R2 and this one. Now, why R1? It is limited to the R1 and R2. Why it is not crossing? Because R1 is a layer 3 device. Similarly, the R2 is also layer 3 device. So as R1 is a layer 3 device, it is breaking the broadcast domain. Correct? So it is breaking the broadcast, and this broadcast is limited to this one. Similarly, this broadcast is limited to this one. So what would be the broadcast domain here in this scenario? Right? So one would be the broadcast domain, this one, right? Broadcast domain 1, and another one would be the broadcast domain, this one, broadcast domain 2, right? Now, there would be the third broadcast domain. What is that third broadcast domain? Is this one. Why? Because if, let's say, R1 sends the broadcast, we have a 3 broadcast domain. One is this one, another one is this one, and then third one is this. Why this broadcast domain? Because if the, let's say, R1 send the broadcast frame, where it will go? It will go to the R2 and it will be dropped after R2, because R2 is again the layer 3 device. It will not forward to the other one. So now you understood the broadcast and broadcast domain. But just think of that. In this one, we break down the broadcast domain from 1 to the 3. But it is not feasible all the time to have the layer 3 device, I mean the router added into this topology, when, you know, because it adds the cost and all those stuff, right? So we need some solution where we can break the broadcast domain without changing the physical domain, right? Without changing the physical topology. In this one, we change the physical topology, right? So let's go back to the SAM topology, and that is where again we have this thing. So let's first understand what is the VLAN in this one, right? So as the name explains itself, the virtual local area network. VLAN is a logical grouping of the device that shares the same broadcast domain regardless of their physical location in the network. What does it mean by that? It doesn't matter that what is your physical location. As far as you are into the one VLAN, you are a part of a one logical group. So what we are doing, we are basically splitting the physical part as virtually into the logical group. So what does it mean by that? So let's say if I have this topology, earlier by default, what I have, let's say sales send the frame, it would go to the marketing, it would go to the IT and sales. It doesn't matter, right? Now, what we can do is that we, without changing the physical location, topology, we can add the VLAN. So what VLAN will do, let's say we configure the sales VLAN 10 for sales, we created a VLAN 20 for IT, and we created a VLAN 30 for marketing. So what is happening here is that it's logically divided. Virtually divided. I won't say virtually divided, because sales become a one broadcast domain, IT become another broadcast domain, means that one VLAN is equal to the one broadcast domain. Right? One VLAN is equal to the one broadcast domain. How? Just think of that. We split it and assign the sales into the VLAN 10, correct? Into the VLAN 10. Another one, we created the second broadcast domain by assigning the IT into the VLAN 20, correct? IT into the VLAN 20. And then we assign third, which is the marketing, right? So what we have done is that we have still the physical SAM topology. We have not added any additional cost of the router or firewall or any other device. We just make the configuration changes that basically allow us to break down the broadcast domain. And at the end of the benefit of the VLAN is it is improving the network performance. It is adding the security. How the security? Because we would be able to add the ACL and all those stuff to protect one network to the other one, right? That's what is the use of the VLAN. So what VLAN is doing? VLAN is basically breaking the broadcast domain, right? Now let's take some of the common interview question related to the VLAN, and that is where we will start with the first question. What is the number of the VLAN that can be configured on a switch, right? How many maximum number of the VLAN we can create, right? So we can create up to the 4094 VLANs. Why? Because the VLAN field is a 12-bit field. So VLAN bit field is a 12-bit field. So how it become a 4094? Let's calculate this thing, okay? So the formula is simple, 2 to the power n, right? 2 to the power n. So here 2 to the power 12, right? N is a 12-bit. Now, if you will calculate this value will become a 4096, right? Now you may say that if it is a 4096, then why I'm creating 4094? Why I'm not able to create the 4096 VLAN? because there are two VLANs reserved, VLAN 0 and VLAN 4095, right? 4095. Now, what does it mean by that? These two VLANs need to be minus from this thing. So if you will minus this two, how much it will become? 4094. So you can create from the 1 to the 4094, correct? Because these two VLAN are reserved, so you cannot create these two VLANs. Right? Now you got the answer of the why we can create the 4094 VLAN. Right? Now, what is the access port? So access port is the port which can carry maximum one VLAN traffic. Maximum one VLAN traffic. Right? So how? Because it basically it assumes that this is connected to the normal laptop or desktop where it is expected to communicate on a single VLAN. It can be communicate on a VLAN sales, or it can be VLAN sales, which means 20 or 30, whatever it is. Similarly for the IT and all that. So a user PC can be a part of the one VLAN, right? So in that case, it doesn't need a tag, right? It doesn't need any kind of the VLAN information to be carried out. So how the configuration look like for that, right? So before that thing, let me, yeah. So if you see here, right, we go into the config mode and, identify the interface where we want to, we are connected with that machine, and then we will configure the switch port mode access, right? So we will tell that port that what you are access, or you are, trunk or anything, right? So you will tell that you switch port mode access, and then you will tell which VLAN you should be a part of. So switch port mode access VLAN. So now this port is a part of sales, right? As per our topology. If you will configure 20, then this will become a part of IT, right? It will become a part of IT. So that is how you can, and you can assign any VLAN as far as you have that VLAN to be available on your switch, correct? Now, another question is that what is a trunk port, right? Let me clear this. So what is a trunk port? So the trunk port is the one which can carry out multiple VLAN. It is opposite to the other one. Other one was the access port, which was carrying out a single VLAN, but the trunk port can carry out multiple VLAN traffic. How this multiple VLAN traffic is possible? By tagging the VLAN information. So what it will do, it will tag the VLAN information to differentiate the traffic is coming from the one VLAN, which VLAN traffic is coming, right? So let's just take an example. Okay, so we have this stop to 01, and then we have another switch 2, right? Now we have a PC connected, let's say IT, okay, and we have the PC from sales, right? We have PC from marketing, right? Now just think of that, okay? Another side also we have similar setup. We have IT, we have sales, and then we have marketing, okay? Now just think of this as a one physical link. If IT want to communicate to the sales, how would it talk, right? Or I mean, IT, this side IT want to talk to this IT PC, right? How they will talk, right? They will come on the switch will forward to the switch, and this will further forward to this one, right? Now, but just think of that. What if I have a multiple VLAN, right? I have to be having some sort of the mechanism where I can color the frame so that the frame, as soon as it is being received, it is this switch is able to understood that, okay, this frame belongs to this VLAN, so I can forward it accordingly. So what it do, we configure this port as a trunk port, right? And that is where we will allow the VLAN 10, 20, and 30, right? So what we will do, we will allow VLAN 10, 20, 30. Now what will happen, that as soon as frame will leave here, the VLAN tag will be put on the frame, and as soon as this one will receive, this will check that tag and will put that frame into that VLAN. So for, let's say example, let's say this guy, let me change the color, okay? So let's say this guy sent the frame, okay? This guy sent the frame, trying to change the color. So this guy sent the frame. As soon as, because this one is a part of VLAN 10, it will map into the VLAN 10, and as soon as it is leaving, it will be tagged with the VLAN 10, and this is where this switch basically will look at VLAN and will put into the VLAN 10 and will forward the. So the frame here would be untagged on this part and this part. So frame on the access port remain untagged. Frame on the trunk is a tag. So just keep it in mind when we talk about the trunk, it is tagged. When the frame is on the access port, it is untagged. Clear? Now let's understand the configuration of it. Let me clean this up. So now if you see here, what we will do, we will go on the interface which we want to configure as a trunk. So we will go on the interface, we will tell that, okay, what kind of the encapsulation we are going to use it to tagging that frame, right? So now all the switches, specifically Cisco, that supports the .1Q, no ISL is supported, and then switch port mode trunk, right? So switch port mode trunk, we are telling that what kind of the port you are you access or you are trunk, right? And then this command is the optional, right? So switch port trunk allowed VLAN 10, 20, 30. What does it mean by that? You are telling that what VLAN to be allowed on this trunk. By default, if you will not define this command, all the VLANs will be allowed. So if you want to explicitly allow the VLAN, you have to define those VLANs that, okay, if I want to add this VLAN, and if you are adding, let's say today you configure this with the 10, 20, 30. If you want to add the another VLAN, let's say 40. In that case, what you will do, you will follow this command, switch port trunk allowed VLAN, and here you will change with the add keyword, and you will, let's say, want to add 40. You will say switch port trunk allowed VLAN add 40, and that is how you will be able to add the additional VLAN 40. Correct? So you understand the switch port trunk. Now let's understand the previous part we were discussing about the .1Q, right? So what is the .1Q here, right? So the .1Q encapsulation is basically the VLAN tagging protocol that adds the 4-byte header to the Ethernet frame to identify the VLAN to which the frame belongs, right? Allowing the multiple VLAN to be coexist on the same physical link. Like earlier we were discussing about the trunk port. So what actually is happening? That is happening because of a .1Q. That VLAN tagging information is placed on the frame, and that is how the other side of the switch identify that VLAN and forward the frame, right? So how does it look, that .1Q? So this is how it looks. If you see here, VLAN 802.1Q virtual LAN, and that is where you see the VLAN ID, right? So VLAN ID means here you see that it is VLAN 123 frame, right? So what is helping to carry out the VLAN information is that the protocol which we connected .1Q, right? It's 4-byte thing, and the frame is working, right? Now next, to understand the native VLAN. What is a native VLAN, right? So the native VLAN is the VLAN that is untagged on the trunk port. In a moment back, you may ask that you were saying that trunk port will carry out the tag traffic. Now you are saying that trunk port will carry out untagged traffic. No, I'm saying that for one VLAN, one native VLAN, you can define it. By default, it is a VLAN number 1. But if you want to change it, you can change it. But that frame can be untagged, meaning that the frame will be transmitted on the trunk port without tag. So what does it mean by that? Let's take an topology, okay? So I have a switch here, right? Switch here, switch 1, switch 2, right? Same topology. We have, let's say, IT, right? We have sales. And then similarly here we have IT, we have sales, right? Now, if you want to forward the frame for the VLAN 10 and 20, you will configure this as a trunk port, right? Now, if you want to carry out any VLAN traffic which you want to be carry out as in the untagged, that where you can see that VLAN to be a native here, right? By default, VLAN 1 is untagged. So what does it mean by that? These frames will be tagged. What frames? VLAN 10 and 20 frames will be tagged, but frames belonging from the VLAN 1 will be untagged. So let's say for an example, if you configure another PC for, let's say, HR, okay, just for an example, okay, and here you have HR, right, and you assign this port as an access port of the VLAN 1. This is a default behavior. So what will happen? The HR frame will be traversing here as an untagged. But just to be clarify that you can have only single VLAN as a native. You can have one, or you can say 40 or 50 or whatever number you want to carry out as an untagged frame. Right? But just to make sure that you have the consistent native VLAN, else it can create a problem, right? Why? Let's say for an example, here you say that HR, this side is going to use the 50 VLAN, okay, as an untagged. And here you see this to be untagged, I mean, native VLAN here is also 50, okay? So native VLAN is 50, okay? And here native VLAN is, let's say you are saying 60, okay? What will happen? HR will forward the frame. This is an access port. As soon as it reach here, this frame will remain untagged and would be received here. Now, since this frame is untagged and here the native VLAN is a 60, what it will do, it will receive the frame, but this will put this frame into the VLAN 60, right? Now, it will forward this frame to the VLAN 60 port, not to the VLAN, which is, so let's say here HR was also 50, right? This frame, this will not be reachable because you send the frame with the VLAN 50 tag and it has been received as an untagged 50, and this is where it is being received as a 60. That is where it would not reach to the HR, right? So you have to have the native VLAN consistent between the two switches, right? Also, make sure that you can only allow one VLAN as a native VLAN. Clear? Okay, let's move on the next topology. So here, let's understand what is the VLAN here, right? So we talked about the VLAN is the virtual local area network, like the name itself explained, right? VLAN is the logical grouping of the device that share the same broadcast domain regardless of their physical location, right? So in this one, if you see, floor 1 is having the sales, right? Also, it have the IT, it have the marketing, right? And then floor 2 have the sales and the IT. So they are into the two different floors, right? They are physically differently located. But if we, let's say, we say that, okay, this one is having VLAN 10, 20, and 30 marketing VLAN, which is configured. And this VLAN, that is where we say that sales is assigned to the VLAN 10, right? And then we assign VLAN 20 to the IT, right? And then we assign the VLAN 30 to the marketing, right? That's what we did. Now, if we see here, 10, 20, 30 is being splitted and they are a part of the one different broadcast domain. So just think of that. One VLAN is equal to the one broadcast domain, right? Another VLAN, another broadcast domain. So if you see here, this one is, let's say, one broadcast domain. This one is a two broadcast domain. This one is a three broadcast domain, right? Now, what is going to be happen? That if they are physically located separate, if sales PC want to talk to the sales, we go to the sales, if it generate broadcast, it would be limited to that lane only. So what does it mean by that? If the sales PC generate the frame with the FFFF here, right, it would be received by the switch. Switch will forward this to the another switch, and that switch will basically forward to the to the PC or any port connected into that VLAN only. Not to the, it would not like that, okay, the frame is generated from the switch would remain be, I mean, would be forwarded to all the VLAN on that switch. It would be limited to that VLAN. So VLAN is doing, regardless of physical location, it is basically splitting the broadcast domain, or it is virtually dividing your local LAN, right? So we have created a VLAN 20, 10, 20, 30, and we have break the broadcast domain, right? Now, what port will look like? So this one would be a trunk port. Why? Because of, like we were discussing, that we need to carry out a multiple VLAN traffic, right? So this port will carry out a VLAN 10 traffic. This port will carry out the VLAN 20 traffic, right? Similarly, 10, 20, and 30, right? But that is why what will be the single VLAN is access port, right? But if I want to just and this one need to be come here, I need to allow VLANs of this trunk port, right? So what will be? This one would be a trunk port. So it will allow the VLAN 10, 20. I'll show you how the configuration will look like for this one. But just think of that. This would be a trunk port, right? Another trunk port would be switch to R1. Why? Because if these tag, this traffic, the default gateway is here on the R1, this traffic has to be come up to the R1, because we cannot let the only one VLAN. If that will happen, the only one VLAN will be able to talk to the to each other, but not to the outside world, not to the other VLAN, because that's how we need to let them communicate, right? Now, how the we will create the VLAN is a simple, right? We have to create this VLAN on both the switches. We need to create VLAN on both the switches, right? On the switch one, switch on the floor one, and switch on the floor two. So command is simple. You will go into the config, you will type the VLAN, and you will give the VLAN number, and then you will give the name. If you will not give the name, it will by default will see the VLAN 010, right? Similarly, the VLAN 20, and that is where you will give the name and so on. So, right? You configure 30 and mark it, right? To verify that if your VLAN is available or not, you can say the so VLAN ID 10 or whatever number you want to check, or you can do the so VLAN. So VLANs are created on the switch, right? So these are the commands to create the VLAN and verify if the VLAN is available, right? Next one, what we have is that let's think of the access port configuration, right? So what will be the access port? Like in the previous slide I was mentioning, the VLAN 10, 20, any port which is going to the laptop or user workstation is the access port, right? So these are the access ports. So how the access port configuration will look like? You will choose the interface number and you will say switch port mode access. By default, just to let you know, all the ports are access. We have to access port. So this one will be switch port mode access, and then we will tell that okay, which VLAN you are a part of, right? So this will be switch port access VLAN 10. Correct. Now we can go ahead and verify if interface is a part of which VLAN, right? So let's say if you want to identify, okay, this interface is a part of which VLAN, you will either go and do the so run interface number, right? Or you can do so interface ETH0 means that whatever the interface number, and you will say switch port, right? So you will say that, okay, this interface number, so interface switch port will tell you what VLAN belongs, right? And you can also do the so VLAN. All three commands will tell that interface is a part of which VLAN, correct? Now, how to configure the trunk port, right? So we understood, we configured this port, this port, this port, this port, this port. But how to configure this one? This is the trunk port configuration. That is where you will identify the interface. Let's say this is, assume that it is a ETH0/1. That is where you will go and tell that, okay, on which protocol do you need to use for a trunk? That's where you will switch port selection trunk. Switch port trunk. You will tell that you are not the access port, you are a trunk port, right? You have to hard code the switch port mode trunk. And then this command is the optional switch port trunk allowed VLAN 10, 20, 30. Why this is optional? By default, trunk port allow all the VLANs until unless you have explicitly removed or allowed, right? So if you will say switch port trunk allowed VLAN 10, 20, 30, it will allow only the 10, 20, 30 VLAN traffic, right? So how to verify that? You can use the so interface number, and that will tell you that it is the trunk port, what native VLAN is, and all that is, right? So that is how you can configure this trunk port and this trunk port and this trunk port, right? So what will happen if the frame will come from this PC? It will be received on this one. Since this port is a part of VLAN 10, it will be mapped into the VLAN 10 table, right? Okay. And then this will be forwarded on this one. That is where it will put the VLAN color number or the VLAN tag number 10. And as soon as it will be received, this will put it into the VLAN 10 table, and it will forward to the ports which is into the VLAN 10, and that is how it will reach to the sales, right? That's it for today's video on the VLAN. We hope you found this video helpful and informative. If you have any question or comment, feel free to leave them in the comment section below. Also, don't forget to like this video and subscribe to our channel for more networking tips and tutorials. Thank you for watching. We will see you in the next video.